Okay, identity number 2. So we're going to look at the left-hand side here. So the left-hand side is equal to cosec theta minus sine theta. Okay, of course we can write cosec theta as 1 over sine theta. That's the definition of it. Remember the third letter is S. So the third letter is S, that means sine. So 1 over sine theta minus sine theta. And similarly then to the previous question, okay, we could, get this as a single term, because if you notice in your answer, that's actually a single term, isn't it? Because they are times together. So we could rewrite that as, keep the first fraction as it is, but the second fraction, well at the minute, it's not a fraction, isn't it? But we can write it as sine theta over 1, and then we can scale it up by timesing top and bottom. If we times the bottom by sine theta, obviously you have to times the top by sine theta for consistency, for balance. So we get sine squared at the top, and we get sine theta at the bottom. So then this becomes then 1 minus sine squared theta, single fraction, common denominator of sine theta. And what we need to remember here then, of course, is another identity from previous year. If you remember, sine squared plus cos squared theta is 1. So if we've got that, then of course, if you fling that over, we can get cos squared theta to be 1 minus sine squared theta. So we can replace the 1 minus sine squared theta with its equivalent, which is cos squared theta, using this. This is an identity as such, a result we can use, and that's over sine theta. Now, we want to get the right-hand side, which to be cos theta, cot theta. Now, you've got to sort of look at how you can manipulate these expressions sometimes. We've got it as a single term, but we need to think, well, we've got a cos theta here, and this is cos squared theta. So what I could do is split this top up and think of it as cos theta times, so obviously it'll be cos theta, but then just put the sine theta underneath that cos theta. I mean, ultimately the whole thing is divided by it, yeah? I mean, I could write it like that, yeah? Because that's what cos squared theta is. But if I actually just divide the second cos theta by it, because that's perfectly fine to do it like this, then of course we've got cos theta, and that there is the definition of cot theta. Because of course, if you remember, tan theta is sine over cos, so cot theta, which is the reciprocal of tan, is then going to be the flip of sine over cos, which is cos over sine. And we get our right-hand side, and therefore it's proven.